Hi, in this video we're just going to talk a little bit about computers and how we use them to create music. Computers are general purpose machines, so they can adapt it to do all sorts of things, and this obviously includes making music. Sometimes it's quite difficult to understand what's going on inside of the computer. We've been using lots of different ways to make music in the past. Now that we've got computers, we've migrated a lot of these approaches into the computer. But because the computer uses the same sort of interface all the time, sometimes it's a bit difficult to tell what exactly is happening. And sometimes that means when we're using the computer, if we don't understand what's going on, it all behaves strangely and it doesn't do what we're expecting. So it's good to have a bit of an understanding about how it all works. Let's start by looking at historically, what tools do humans use to make music? Well, traditionally, besides using our bodies, we usually use particular machines to help us, which we call musical instruments. What a musical instrument does is it gives real-time control over the sound that is produced. So we can use that to express ourselves musically. Typically, a performer will control things like pitch, loudness, timbre, and timing. Different types of instruments do different things. They have different control possibilities and they generate their sound in different ways. Each of these sort of designs has got different strengths and weaknesses, or it has different possibilities and limitations. And what has happened, we found useful possibilities for a particular type of instrument and useful different possibilities for others. That's why we've got ancient musical instruments that have kept on evolving and still basically survive, while there are lots of other instruments that have been invented over the years which have essentially disappeared. One thing we should talk about is most of the instruments that we use these days are designed to produce discrete events, which we normally call notes. And that's the way we tend to make most of our music. If we think of an instrument, then that instrument breaks down into three components: something that generates the sound, some way of controlling that sound that's generated, and often something which will take that sound and change it in some way. Let's use the violin as an example. So the sound generator is the strings which are stretched over the resonating body. The controller is the fingerboard, which enables us to change the length of the string, and the bow, which enables us to shape the sound. The effects processor. What effects processor is there in a violin? Well, it's often the room. If you were to go into a dead room, a violin sounds completely different to how it sounds in a live concert hall. We normally don't listen to instruments just anywhere. We tend to listen to them in actual concert spaces. So that's a type of effects processor. When we're going to use a computer as an instrument, it opens up new possibilities that we've never had before. When building musical instruments with the computer, we can just emulate the components of either acoustic, electric, or electronic instruments that we've had before. Or we can use the computer to build something which is unique. Both ways are valid. So with computer-based instruments, these different components can be in separate apps, or they can be all parts of a bigger app. We can have a controller app which sends signals to a generator app which sends audio to a effects app, or they can be all together in one big app. Now, what this means is we can often mix and match the different components. One type of controller can control a particular type of sound generator, which then sends its signal into a different effects processor. I like to think of computer software as being in one of two paradigms. One is where it's designed as if the computer is an instrument, And there are other apps where it's designed that it's not a musical instrument, it's just an audio processor. They manipulate audio signals directly. Software like this includes audio recorders, audio editors, effects processors, and music visualizers. These are the typical things we need to do in recording studios for the last 70 years. We can think of this sort of software as working with streams of sound. We have a stream of sound and we manipulate it in some way. Maybe we've got a bunch of different streams of sound and we're all combining them. If you think about it, in the sort of applications we use to consume audio, like Spotify, for example, or even YouTube, the audio is a stream of sound that comes out. We can manipulate it, we can mute it, we can make it louder or softer. We might even be able to put some equalization on it. But essentially, we're thinking of the sound as just a stream that flows past us. Now, software that uses the instrument approach is conceptually different. If the instrument approach is used, then the software doesn't work at streams of music, it works at the level of discrete musical events. We normally think of musical events just as notes, but there are other types of musical events as well. If we were playing a piano, we might put our foot on the sustain pedal. If we were playing an electronic keyboard, we might turn some knobs. All of these things can be captured as discrete musical events. The way this sort of software works is we get our notes or other events and we put them into some sort of database. Once we've got all of these notes in the database, we can manipulate it in some way, and there's normally some message-based system to enable us to do what we need to do. So, how do we put notes into the database? Well, lots of different ways. We can use special software to record human performance gestures on special machines that emulate traditional musical instruments. This is a very complicated way of saying is we plug keyboards in and we play them. So we have special software which can record what's coming in. The special machines, which look like keyboards, for example, send messages to the special software, and then the software says, oh, I'll put this in the database. Now, another way we could do it, instead of using those special machines that look like instruments, like keyboards, we can use the computer keyboard to enter notes. Then it's kind of like entering data into a spreadsheet. Of course, we can use the computer keyboard to try and emulate a musical keyboard also. Another way of entering musical events is to use a point and click paradigm using our mouse or our trackpad. So we've got some sort of graphical interface and we put the cursor where we want, click, and a note appears. Once we've got the notes that we want stored in the database, then we can do things with it. We can play it back so that this data can play some software instruments. If we want to, if the data's got issues, we can edit it. We can change the notes. There was a wrong note, so we fixed it. Or that note was too soft, so we made it louder. This note is out of time, so we fix it. We can also use algorithms to transform the notes. Say we've got a bunch of notes in a database and we want them all to be an octave higher. The algorithm goes in, takes the notes, makes them an octave higher, and stores that back in the database. We can also use algorithms to generate new data, that is to compose new notes. So we can do all these sort of manipulations. And of course, we need to be able to see what we're doing. So often there are ways of displaying the data in the database with some sort of graphical notation that enables us to understand what's going on. It could look like a traditional score, or it could be some other sort of graphical representation. Let's have a look at some examples of types of software that are based on this idea. There's obviously software which is trying to be a musical instrument. There are also things called sequencers, which are designed to play software instruments. There are also music notation programs, which are designed for you to input and edit music, and normally you want to use those to print out onto paper so that musicians can play what you wrote. And of course, there are composition programs. These can be real-time programs, or they can be programs that work out of real time. Lots of different possibilities. So, in the 1980s, manufacturers came up with a standardized way to enable computers to communicate about music. And this was called the Musical Instrument Digital Interface. MIDI made it a lot easier to connect things together. We could control the sound generator with any type of controller as long as they both use the MIDI protocol. MIDI was so effective that it was adopted throughout the music industry, and now it's kind of become synonymous with the idea of the computer as a musical instrument. Over the last 30 years, there's been a trend towards using big applications that combine both paradigms. So we've got audio streams and software instruments. Everything is inside one big box. And these programs we call digital audio workstations. They try to do everything. They're very complicated, and you can think of them as a box full of tools. Some common DAW examples are Logic Pro X, Pro Tools, Ableton Live, FL Studio, Cubase, Reason, and a bunch of others. If you look at DAWs these days, you realize that they all do the same thing, but they do things in slightly different ways. What tends to happen is that if a particular manufacturer comes up with a useful new technique, the other manufacturers will make their own versions of that and introduce that into their programs next year. So we've got all these DAWs, they all basically do the same thing. Why do we have so many different ones? Well, because they tend to use different workflows, and that's what sets them apart. Different workflows may make them more optimized for particular tasks. Say, for example, we're going to be recording different layers of sound in a recording studio where everything is live and there are no synthesizers involved. Maybe we might want to use Pro Tools. If we're doing something which has got a lot of software synthesizers, we may want to use Logic or Ableton. So, understanding which parts of a DAW are concerned with working with streams of audio and which parts are working with virtual instruments can help us effectively use DAWs to actually create something. Remember, we're not using these things just to play with software, we're using these things as tools to create some music. The software is a means and not an end. If we understand the underlying principles, we can make better use of these tools.